Welcome students. Myself Dr.Monika Khetarpal. I am Associate Professor of Physics in Government Dungar College, Bikaner. I am dealing with the fifth paper of MSc Final Physics. We were discussing superconductivity. Today I am going to tell you some basic questions on superconductivity. The first question with which I am dealing is gold a superconductor? Students, we already know that gold is a very good conductor of electricity. We know that the best conductors which are available at room temperature are gold, copper and silver. These materials are best conductors, but these materials do not turn into superconducting material on varying the temperature. So it is not necessary that a material is a good conductor, then it will become a superconductor. The next problem is I am given the susceptibility of magnetic material to be 0.9853. I have to identify the type of magnetic material. Now, since I have given that susceptibility of this magnetic material is plus 0.9853. We know that if a material has chi, that means magnetic susceptibility positive, then the material will be paramagnetic in nature. So the given magnetic material is paramagnetic in nature. The next problem is give two properties of magnetic material having negative magnetic susceptibility. We know that magnetic susceptibility is a dimensionless property and its sign, positive or negative, it determines the type of material. If the susceptibility is positive, as in this numerical, the material was paramagnetic, and the materials having negative susceptibility, these materials are diamagnetic in nature. Examples of diamagnetic substances are copper, iron and superconductors. We have shown that chi for superconductors is negative. So superconductors have negative magnetic susceptibility and they are diamagnetic in nature. Negative susceptibility also show that they are diamagnetic and hence they will be repelled by magnet. The another problem is that susceptibility of magnetic material is 2.6 into 10 raised to power minus 5. I have to identify the type of magnetic material. Now, here in this problem, that susceptibility chi is positive. So, we have already said that a material having positive susceptibility will be paramagnetic in nature. The other problem is a room temperature superconductor possible? A superconductor at room temperature is capable of showing superconductivity. The temperature must be around 77 degree Fahrenheit. The next problem which I am going to discuss is why is a superconductor a perfect diamagnetic material? I am taking a superconducting material and placing this superconducting material in a magnetic field. Then it is found that magnetic field lines, they are pulled out of the material. That means inside the material B equal to 0. And we have already determined that chi for superconductors is negative. Hence, when they are cooled under a critical temperature, the negative susceptibility value shows that these materials are diamagnetic in nature. The next problem is, what is magnetic levitation? This magnetic levitation is based on the diamagnetic property of superconductor. Diamagnetism is present. That means there will be rejection of magnetic flux lines. We can suspend a superconductor in air against the repulsive force from a permanent magnet. This magnetic levitation effect can be used for high-speed transportation trains without a frictional loss. The next problem is, what is SQUID? SQUID means superconducting quantum interference device. I am already tell what are Josephson effect. A Josephson junction is formed when two superconducting devices, they are separated by a insulating layer. We are taking a double junction quantum interferometer. The two Josephson junctions, they are mounted on a superconducting ring to form this interferometer ring. And the magnetic flux inside this ring is quantized. This SQUID, they are used to detect magnetic signals, and the magnetic signals must be of the order of 10 raised to power minus 14 Tesla. So SQUID is a very important device which can detect magnetic signals inside the body. The next question is, what is the value of quantum of flux in a vortex of superconductor? The value of flux quantum is phi0 is equal to h upon 2e. Here the physical constants, h is the Planck constant, e is the charge of electron. So the value of flux quantum will be 2.07 into 10 raised to power minus 15 Tesla meter square. It is a constant, so it does not depend on the type of material. That means it will be same for every superconductor. This quantization is due to the existence of condensed combination with the formation of collective Cooper pair. Another question is, give the example of liquid and gas in which vortices are observed. These vortices are observed in superfluids, and they are even observed in Bose-Einstein condensate. These are the two similar forms of superconductivity for liquid and gaseous phase. The next question is, I have to tell the difference in Meissner effect in type 1st and type 2nd superconductor. In type 1st superconductors, when we place a material in a magnetic field, it is observed that flux is totally excluded from the interior. That means inside the superconductor, B is 0. But when we switch over from type 1st to type second superconductor, its behavior is totally different. In type second superconductor, at a particular field, let us denote it by Hc1. Till this field, the magnetic field will be excluded from the interior. That means B will be 0 up till Hc1. And now increasing the field till Hc2, the magnetic field will penetrate inside the material. That means between Hc1 and Hc2, the magnetic field penetrate partially. And at Hc2, the transition takes place to a normal state. The state between Hc1 and Hc2, this state is known as mixed state or vortex state. And Hc1 is the lower critical field. Hc2 is termed as the upper critical field in type second superconductor. The next question is, I have to write the difference between type first and type second superconductor. I have already explained the Misner effect in these two types of superconductor. Misner effect is totally followed in type first superconductor. That means before the transition to a normal state, B is totally 0 inside the superconductor. Whereas in type second superconductor, B is 0 until Hc1. After that, magnetic field begin to penetrate, and at Hc2, material becomes normal, and between Hc1 and Hc2, there is a partial magnetic field penetration inside the superconductor. Type of transition. In type first superconductor, since there is a transition from superconducting state to normal state, and this transition is sharp at a critical field Hc. This transition in type second superconductor takes between Hc1 and Hc2. The value of critical field is low in type first superconductor. It is very high for type second superconductors. Type first superconductors are soft superconductors, whereas type second superconductors have a name. They are termed as hard superconductors. Example of type first superconductors are mercury, niobium. The example of type second superconductor are ceramics and alloy. Both type of superconductors have numerous applications. Type first superconductors are being used in magnetic coils, whereas type second superconductors are used in permanent magnets. So these are some basic questions that we must learn to know what are superconducting materials. Thanks a lot for watching.